16.6, signs of f, f prime, and f double prime of integrally defined functions. So this builds off of lesson 16.5, where we're going to actually find all three things on the same problem. So we've got f graphed, g of x is the original function, this is the derivative. Let's first find g of 4. So g of 4 just replaces 4 here, which then puts 4 here, saying our bounds go from 4 to 4. So we're finding area under this function from 4 to 4 f of t dt. Now from a number to itself, I'm not making any shape. I don't have an area of anything. So that would equal 0. So right here you'll have a drop down menu and you'll pick the one that says is equal to 0. Okay, then let's do g prime of 4. So taking g prime is going to be taking the derivative of this, which cancels. So that's really going to be f of x, or f of 4 is what they want us to put in. So I'm literally looking on this graph and finding f of 4 right here. And that is the point 4 comma 0. So actually that also equals 0. And then I'm finding g double prime of 4, which would be priming f, so that's actually f prime of 4, or the slope at x equals 4. Slope, you're not going to know for sure, but you know that this is increasing, so it's positive, so you would just say that it's greater than 0, is all you need to do. All right, let's try number 2. Second part of this assignment is then multiple choice is putting them in order least to greatest. So you'll probably have one that's 0, one that's negative, one that's positive. But other than that, same thing. So we're going to find g of 5. That would say area from -5 to 5 for f of t dt. So -5 here. So we'd have this area, and this area. And this little area. You're not going to have a number, but you can approximate here. Looks like I have way more negative area than I have positive. So I would say that this is going to be a negative value, or less than 0. Okay, let's do g prime of 5. You're going to plug or take the derivative, so that really equals f of 5. So at 5, y is 2, which is obviously positive or greater than 0. And g prime of 5 is going to be f prime of 5, because I'm taking the derivative and the derivative. So slope at 5 looks like a horizontal tangent line, so that would be equals 0. So we would need our -1 first, so that's g of 5. So it's one of these two. Then that's less than, we would want 0, our second derivative, and then that's less than our positive 1. So that would be the answer.